Hi, my name is Ian Grace, and I'd like to introduce you to my final project for GIS 410-510. I decided to look at glaciers in Norway, specifically the retreat or advance of glaciers. Of course, because of climate change, primarily we see retreating glaciers all around the world. Jostedalsbreen Glacier in western Norway is one example of a sensitively reacting maritime mountain glacier, and is also one of the most heavily visited and easily accessible glaciers in Norway. Mountain glaciers are excellent indicators of climate change, and Jostedal and its outlets have received considerable attention due to its partial disintegration, specifically that of many of its lower glacier tongues. My goal is to determine the retreat in two-dimensional area only, or advance of two Jostedalsbreen glacier tongues, Boyabreen and Nygaardsbreen, which are about 40 kilometers apart and lie on the southern and northeastern edges of the main Jostedal Glacier respectively. I've already determined the answer to my first analysis question, which is, what is the total area difference of the Boyabreen Glacier arm between 2011 and 2016 in acres? The answer to this is 41.7 acres has been lost. The second question is, what is the area difference of the Nygaardsbreen Glacier arm between 2007 and 2010? And the third question is, how many residential or urban areas are within 50 kilometers of Jostedal's epicenter? Here you can see some Google images of Jostedal National Park and some of its glaciers, glacier tongues. I'd like to point out I just picked Norway because I don't usually think of Norway when I think of climate change, or at least glaciers. Obviously there are glaciers here, but I think largely people think of other countries, especially Greenland or Antarctica, when considering climate change and glacial retreat and melt. The data that I'm using for this project is largely self-created. I used Earth Explorer to find images, Landsat 5 images of Norway, Jostedal region in October of 2007, 10, 11, and 2016. These images were downloaded as tar.gz files and then imported into Envy. Using Envy and bandmath and layer stacking, I created true color RGB images from the Landsat 5 data and then imported these images directly into QGIS. I used QGIS to create polygon shapefiles over both glacier tongues, and I'll also use it to create vector points for Norwegian cities, towns, and villages for the third analysis question. Then I imported these shapefiles to ArcMap, where I continued analysis. In total, the starting data per se was Nygaardsbreen 2007.shape, 2010.shape, and Boyabreen 2016, .shape, and 2011.shape, and the four raster images that I created. The data is in WGS 1984 UTM 32 North, which is Norway's UTM zone, and I projected and defined the projection and projected the rasters and shapefiles according to this. Then I used the erase tool in ArcMap, once I imported everything, to essentially subtract the shapefiles from each other. Since drawing shapefiles in QGIS resulted in imperfectly aligned shapefiles, I used the draw feature to consolidate the subtracted shapefile, essentially getting rid of slivers that resulted from subtraction, and drew a polygon around the part I wanted to keep and clipped the shapefile to that polygon. For Boyabreen, right now we're looking at Nygaardsbreen, the upper tongue increased in area and the lower tongue decreased in area. So I subtracted 2011 from 2016 and 2016 from 2011, finding the area that was gained and lost. Again, the net loss was 41.7. I expect that this glacier tongue, the Nygaardsbreen arm, will have a similar retreat. I've already begun looking at it. Here's the 2007 image shapefile, and here's the 2010 shapefile. Here's the total lost area in white here. I then pushed everything to ArcMap. You can see I have details, tags, credits and attributions, and access and use constraints, and so forth. And here's the actual map. Here's Norway. Here's the Jostedal glacial region. And here is the Boyabreen arm. And you can see in red that we have the decreased area, or the retreated area. In blue we have the current area, the 2016 area, and in green we have the increased area of the upper glacial tongue.